Audrey's science class built a model rocket. They launched their rocket outside. It cleared the top of a 60-foot high pole and then landed in a nearby tree. If the launch pad was 2 feet above the ground, the initial velocity of the rocket was 64 feet per second, and the rocket landed 30 feet above the ground. How long was the rocket in flight? And then we're given an equation to use. So the first thing we need to know is how to plug each one of these values into the equation. So the launch pad being 2 feet above the ground, that part goes right here. That h is the height above the ground when it was launched. And then the speed at launch, the 64 feet per second, that's the v for velocity that goes right there. And then the height at which it lands, 30 feet above the ground, so lands in a tree, that's going to go right there for h. So before we start solving it, let's go ahead and plug in our values here. So 30 equals negative 16t squared plus, and then we're going to replace the v with 64, 64t plus, and then the height above the ground is 2. Okay, so this is an equation, and when we have an equation that we're going to solve by factoring, which we know we're going to solve this by factoring because it has a squared in it, t squared, and also a t. If it had just t squared, we might not have to factor. We might be able to do a square root thing, but because it has a t squared and a t, we got to solve it by factoring. And when you're solving an equation by factoring, it must equal 0. So step 1 is going to be subtract 30 on both sides so that this equals 0. And we will combine constant with constant. So the 16t squared is unaffected. The 64t is unaffected. And then the 2 minus 30 is negative 28. Okay, so now we're ready to factor. We're going to factor negative 16t squared plus 64t minus 28. And the first question we ask ourselves, as always, is there a greatest common factor? Is there something 16, 64, and 28 can all be divided by? And the answer is yes. They can almost all be divided by 16. 16 and 64 can both be divided by 16, but 28 can't. But they can all be divided by 4. So there's a greatest common factor of 4. So let's go ahead and factor that out first. 0 equals, and you know what? Since this starts with a negative 16t squared, let's go ahead and factor out a negative 4. That'll make life easier for us. Let's do a negative 4 outside parentheses. So we're going to divide everything by 4 and change all the signs since it's negative. So our negative 16 divided by negative 4 is a positive 4. 64 divided by negative 4 is going to give us, let's see, was that 16? So negative 16t, because we changed the sign. And on the end, negative 28 divided by negative 4 is positive 7. Now, in previous problems where we factored and also had a greatest common factor, we've just left the greatest common factor in front of the parentheses. But with an equation, we don't have to do that. There's actually something pretty simple we can do to get rid of the negative 4. This is negative 4 times a set of parentheses. Let's just divide by negative 4, and that will cancel these negative 4s, leaving us with just 4t squared minus 16t plus 7. And you're thinking, well, wait, hold on. If you divide one side by negative 4, don't you have to divide the other side? Yes, but what's 0 divided by anything? 0. So by factoring out that negative 4, what we have essentially done is just cancel a negative 4. Just reduce everything, make the problem smaller, which is awesome. I like smaller numbers better than big numbers when I have to do factoring. Okay, so now we're ready to factor, and we're going to have to factor by grouping because it is not just a t squared, it's a 4t squared. So we got to do some grouping. So we're going to do a times c, which is 28. And so I need two numbers that I can multiply to get 28, but when I add them, I get negative 16. And I always like to start off with the two numbers that gave me the 28 in the first place. I don't know why I do that. But negative 4 times negative 7 is 28, and negative 4 plus negative 7 is -11. Not -16, but place to start. How else can I get 28? Oh, I like 14 and 2. 14 and 2 will get the job done. So -14 times -2 is +28. And then -14 plus -2 is -16. Okay, great. I like that a bunch. Okay, cool. So why did we get those two numbers? Because we're going to factor by grouping. Factoring by grouping requires 4 terms, and those two numbers are what we're going to split that middle term into. So our first term is 4t squared, but that middle term, -16t, is now going to be -14t minus 2. So I'm going to do, let's do -2 first, and then -14, because I'm seeing the next step here. And 4t and 2t have a nicer common factor, and -14 and 7 have a nicer common factor. Oh, whoops. Sorry. Got to decline that one. Oh, don't tell Mrs. Taylor I declined a call from her. So, factoring by grouping. All right, fine. I'll answer the call. All right, sorry about that. She was calling to say she loves me and can't live without me. And I'm the apple of her eye and the joy of her morning. So, we're going to group these first two. And the greatest common factor of these is 2t, leaving us with 2t minus 1. And then the greatest common factor of these is 7, but because it starts with a negative, we'll factor out a -7. And hey, what do you know? That also leaves us with 2t minus 1, which is good news. Our parentheses are the same. So one set of parentheses for our answer is going to be 2t minus 1. And the other set of parentheses is going to be 2t minus 7. And don't forget that it equals 0. So either 2t minus 1 equals 0 or 2t minus 7 equals 0. So those are the two equations that we'll solve. 2t minus 1 equals 0. 2t minus 7 equals 0. And both of these are one-step problems. Not too difficult. We'll add 1 to both sides and divide by 2. So one of our answers is a half. And over here we'll add 7 and divide by 2. So our other answer is 7/2. Or if you like decimals, it'd be 0.5 and 3.5. But who likes decimals? Okay, 1/2 and 7/2. But let's go back to the problem and make sure that both of these answers make sense in context. It says, how long was the rocket in flight? How long was it in flight? So the time is from 1/2 to 7/2. And so the amount of time that it was in flight from half a second to 7/2 seconds. So the time that it was in flight is the difference between 7/2 and 1/2, which is 6/2. So 3 seconds is how long the rocket was in flight. So apparently there was, I don't know, a half a second where it was building up thrust or something before liftoff or something like that. Regardless, the rocket was in flight for 3 seconds. So we know how long it took before it launched, and we know how long it took before it landed in the tree. And that time was 3 seconds, 3 seconds that the rocket was in flight.